really excited to introduce our very good friend, because I think everybody knows Marcy. I mean, she just is amazing chemistry education researcher. Every time you look up something, Marcy has published something about it. The scope of her work is amazing. I could spend 40 minutes talking about Marcy, but I want to let Marcy talk. So I'm just going to mention two things. The first is two very prestigious recent things. She was the winner of the 2019 RSE Nyholm Prize. This is sort of the preeminent prize in chemistry education. And Martin Poliakov, who you saw in Anna's talk, was a previous winner. So this is really people at the top of their game. So congratulations to her. Unfortunately, that means she can't come to the UK this year, but we are really looking forward to having her next year for her Nyholm Prize tour. And just recently, her own department in Purdue recognized her amazingness and have awarded her a named chair, the Bodner-Honig Professor of Chemistry Education chair. So congratulations to her on both those counts. And I think we are all very excited and ready to hear from you, Marcy. Are you able to turn on your audio?
Yeah, okay.
Yes,
so
great.
But what I'm looking at, which is making me rather nervous, is I've got the screen that looks like it looks like.
Yeah. So if you go to End Show in your top left-hand corner.
Yeah.
And then
okay.
we have, so in slideshow, I think if you
Marcy, if you go back to that presentation, next 2 buttons over from End Show is Switch Displays, and that should show us the other version.
How about
there?
that?
Thank you very much, whoever that was. Thank you.
Okay, thank you. Whoever did that. Okay, so you know, one of the best things about being involved in this symposium is I've tried to sort of change the talk as I've gone, so to integrate what people have said. So, you know, one of the things I think that we're all facing is that everything is now different. Certainly for us, we had, I don't know, maybe 12 days time to go from teaching face-to-face and having face-to-face labs to now where everything is different. As Ian said, you know, how do you teach labs with no teaching labs? So how do you move from a face-to-face environment to a more online environment? And associated with that are things that we've talked about all morning throughout the talks. You know, what learning outcomes do we have? And then, you know, how can we possibly assess them in an online learning environment? So what I'm going to introduce and use to frame my talk a little bit, and this is going to look like a tasting menu. There are 3 different pieces and parts I'm going to talk about. But broadly, it's about how do we support student learning and engagement in something that we call science practices. And the science practices come out of a piece of work from the national academies here in the United States called the Next Generation Science Standards, or it's associated with the national academies. And these science practices, I'm going to talk about badging a little bit, although others have touched on it. And that's sort of nestled in that in-between space where students plan and carry out investigations, and then they analyze and interpret their data. I'm going to also talk about something called claim evidence reasoning, which if you're not in chemistry, gets called CER a lot. And it has to do with driving students towards the ability to develop an evidence-based argument. So constructing explanations and engaging in argument from evidence, which is something that we hope every scientist can do. And then last but not least, as you move your institutions into this online environment, I'm going to talk about the online laboratory notebooks that we've used. Magna had a poster about her experiences with OneNote, and we just heard Ian's talk about learning sciences. And so I'm going to talk a little bit about what we've done at Purdue. So the digital badging movement, clearly from Stephen's talk onward, people are pretty well acquainted with it, and they use it a lot. Here at Purdue, I never could have done this work without Cindy Harwood and Sarah Hensick, who's now Sarah Hewitt. And I'm just going to talk just a tiny bit about digital badges. But the idea is, you know, that the evidence is crucial. We first got into digital badging and developed a digital badge for pipettes, for volumetric flasks, for burettes. We've published 2 articles in JCAMed. We've published an article in the Journal of College Science Teaching. But beyond the student hands-on skills, our university is this large university in the Midwest. We run somewhere between 8,000 and 9,000 students through our general chemistry program every year. So the big thing in terms of US dollars is we've probably saved across the lifetime of this implementation somewhere close to $20,000. And it's simply because the students know how to use the equipment and they don't break it as often. I'll be honest about that. But beyond what we've done at Purdue, certainly Michael has played a huge role in the chemistry community in driving this work forward in terms of developing them for both high school chemistry and at uni. And so make sure you've read his article, which is freely available, this Using Digital Badges for Developing High School Chemistry Lab Skills. That's an ACS editor's choice, so it's freely available around the globe. And then of course, he's got a fabulous website. And then, you know, all the more reason to get up here early in the morning in the States as you find out, hey, there was something in active learning in higher education that came out of Tina's group that I hadn't even seen before. So I'm gonna look forward to reading that after the conference is over and before I start to have my whiskey or my gin and tonic, as other people are doing, I think, during the coffee break. So one other relatively new idea in badging that I wanted to share and make sure people were aware of is there is conversation about how long does a badge last. And we've got some research that would indicate that it does last more than 1 semester. And the way we went about doing that is there were years where we had our 2nd semester general chemistry class and we would just have them do the basic badges again, and the pass rate was tremendously high. We looked at 220 student videos. 216 of those students passed and got recertified on the same badge that they had done in the fall. Of the 4 students who didn't pass, 2 of them had mistakes and 2 of them just resubmitted their fall video, which we denied and said, no, you got to do a new video. So we felt like we had lots of evidence that that the certification would last more than 1 semester. So what we've gone to using in the 2nd semester course that we use now, and we're in the 2nd semester up here in the Northern Hemisphere in the States, and we use these advanced badges and they can be implemented online. So they've been really useful this school year. They're more about appropriate laboratory practices than they are about directly showing us that you can use hands-on skills. So I'm going to zip through these pretty fast, but if you haven't seen them before, it gives you an idea of, okay, well, what would an advanced badge actually look like? So here's one for the advanced volumetric flask, and I'm going to hush for like 5 seconds and let you look at these. Okay, so the basic idea is it helps them think a little bit about their lab skills and a little bit about what's a dilution all about. So in the first case, the liquid's below the level of the calibration line. You know, do you actually have it diluted to 1 molar? Explain your answer, and then what would you do next? And then solution 2. So first of all, that image did not appear in the badge itself, but I've put it into the presentation so people get the right idea. But it's essentially the student mistake where they add too much water to the flask and they fill it up above the calibration line. And it's really important to ask them what you would do next. And the thing I want people to know is that, okay, well, here's what a correct response actually looks like. This is what the students should tell you, but there are plenty of students who do not do that. So here's a sample incorrect response where the student does recognize that they've added too much water and the level of the liquid's above the calibration line and it's too dilute. But then what are they going to do next? Well, they're going to remove water. So they're going to suction it back out, actually the solution, until the level of the liquid was at the calibration line. Now, some of you may be saying, well, really, if they're just dropping it in, the amount of solute that is in the solution at that point is not that large, and so the level of error is really not that high. But the truth is, this is not the kind of lab practice that you want to encourage your students to engage in. So this is a place where we interact with the students and we try to point them towards, here is why you do not want to do this. And really what you do want to do is start completely back over. So this is an advanced badge where we get a lot of conversation. Here's one with pipetting. The first one just essentially is, hey, you have bubbles in your pipette. All the students can figure out that, okay, you have less than 10 milliliters. This is not a good thing. You drain out the liquid and you suction it up again. The second one, where your partner's using the pipette and they squeeze the bulb so hard that it pushes all of the liquid out. Boy, we have lots of students tell us they dispensed exactly, or the student dispensed exactly 25 milliliters because the meniscus was at the calibration line. That's a very, very common response. And so getting them to understand that, okay, you need to go take a look at your laboratory notebook, which has this exact image that the pipette's calibrated to retain a small amount of liquid. You never blow out the remaining amount. And what you're hoping is then the students will realize, okay, well, that must mean that this is the wrong practice. It doesn't matter that the meniscus was at the calibration line. And that you've actually delivered a little bit more than 25 milliliters. And so this is not what you want to do. And then last but not least, we've got an advanced burette badge. And the first question is just about, recording volumes from your burette. How many places past the decimal point do you use? Many students know it's 2 places. You estimate that last hundredths place. But must you begin at 0.00 milliliters? There are a lot of students who think that, yes, you have to do that. And what I fear is that some may have come out of their high school experiences thinking that, hey, you have to start it at 0. And so the way we try to get students to think about that is to ask them, okay, when you record your data, how then do you determine the volume of liquid that you've actually delivered? And that helps them realize, okay, it's just a subtraction. It makes it easier. I get that a lot. It makes it easier if I start at 0, but I don't have to. And that sort of helps them. So these advanced badges, I think the big thing you can do is you can still do these kinds of things in an online environment. Focus on common errors, ask the students what they would do next, and that seems to be a helpful way to go. So touching back with our scientific practices, where am I going to go next in my tasting menu? So what I'm going to slide over and talk about is bringing research streams together. So one of the things that I had done research on, and I'd worked with Renee Cole and her student Courtney Stanford and my students Nicole Becker and Alina Moon, we had done a lot of argumentation research, and we had done research where we had dissected student discourse and talked about things that develop as if they're shared pieces of knowledge in the classroom. And alongside of that, I've always had this abiding interest in laboratory. And a lot of that comes from conversations that I had with Stacey Lowry-Bretz across the years and her students. And it's one of those moments where you know you have these two pieces of research and you know you should do something different in laboratory to help students, you know, be able to write arguments and to construct explanations. And it's just sort of things that are wandering around in your head, and I just could never land on a spot that I was very happy with. The other influencers that I had in my head, besides that research, would be Joy Walker's Argument-Driven Inquiry. And I've included a couple of Joy's references down low. And the Next Generation Science Standards, that science practices piece. And then last but not least, some of Melanie Cooper's research where she talks about constructing an evidentiary argument. And, you know, it can be really frustrating as a researcher, and you're trying to translate your research into practice, and you want to improve student learning. You want to do something different in laboratory and in your classroom, and I just couldn't get there for some reason. My brain didn't fire until last summer. I was looking at something called the ChemEd Exchange, and this is just a screenshot of the ChemEd Exchange. And the thing I want to share with you straight away about this is they are doing open access to their resources during the COVID-19 crisis. That's what's in the red box at the bottom. And I happened to be on that site last summer, and I bumped into something called a claim evidence reasoning sheet. And all of a sudden, this light bulb went on in my head, and I went, this is it, this is it, oh my gosh. This is how you take all those influences, the prior research that we had done about argumentation in laboratory, Joy's ADI idea and all her research behind that, the Next Generation Science Standards and the science practices, and building an evidence-based argument, and Melanie's research as well. So I'm going to get to the lab part in just a couple of slides, but I'm going to walk you through what a claim evidence reasoning sheet looks like and can focus on. And I'm going to start with something on purpose that is not about lab, but it's really sort of simple, so I can talk my way through it. So say, for example, in your classroom, you have a sheet of paper, you've got these 4 Lewis structures on it, and you ask students to make observations about these Lewis structures. You know, what do they notice? What can they figure out from them? And you kind of give them some prompts to do some observation work. And then you ask them to make a claim. So that's the C in the CER. And you don't want the students to walk out in the world and make a claim completely undirected. You want to give them some direction. So a prompt is a really good thing to have. So in this case, the prompt might read, which molecules or molecule or ion are polar? Okay, so then they have to write out a claim about, okay, which of these 4 things are actually polar? And then you ask them about their evidence. You know, how do you determine if a molecule is polar? What observations, or what, because they've made some observations, but what principles, what concepts might you use? And you help them think about the pieces of evidence. And then you hit the reasoning part. And this is where you really are helping students to work on developing an evidence-based argument or constructing explanations. So you tell them, okay, you're going to explain your reasoning here, you're going to connect your evidence to your claim, and you're going to use your observations, your principles, your concepts, okay? So this is the kind of thing, what I want you to envision is this is the kind of thing you could do in your lecture or in your recitation. This is a kind of, you know, guided, structured thing that you might implement to help them think about polarity, okay? So I'm gonna go over and talk a tiny bit about, you know, what the research would tell you. So what we know from argumentation research and from Joy's ADI research is that it is not sequential, that students make a claim, think about the evidence, and then write out their reasoning. So what I want you to know is it bounces around, it bounces back and forth between these things, and it is iterative, and that's perfectly fine. Okay, students, and especially if you allow them to talk to each other while they're filling out a sheet like this, they're gonna go back and forth and think about these things. In Melanie's work, one of the things that she will do in some cases is give the students the claim. She'll straight up give them the claim and then ask them to supply the reasoning. So that's another way to structure assignments or tasks like this. You can go ahead and give them the claim. That's fine. You know, show them the data that you're looking at, the graphs you're looking at, the images you're looking at, whatever it is. And go ahead and give the students the claim, but then ask them, you know, how is the claim tied to the data, tied to your evidence? And then the really interesting thing I found on the ChemEdX website that was very interesting. ChemEdX has a lot of high school, so sort of middle school, high school teachers who have contributed ideas and contributed their sheets. In some cases, the directives about the writing of the reasoning is really structured. So they tell the students, okay, your first sentence is, you're just gonna restate the claim. And then the next directive is, okay, whatever you've written down for your evidence, you need to talk about each piece of evidence. And that, in that structured way, it helps the students with their writing, and it helps them to sort out the evidence in some cases. So that's part of the rubrics you can find on the website as well. So if you're sitting there going, well, you would grade this with a rubric, wouldn't you? Yes, and those rubrics, you can find them on the ChemEd Exchange. And there is, you know, some sense of, you want students to use the right pieces of evidence. And so trying to direct them that way is important. So let me show you what an examination task looks like in this case. So this examination task is something that I believe we gave this past, on the first exam this spring. So they have a set of molecules up at the top. We've drawn the Lewis structures up there. We've asked them to identify the intermolecular forces present in a pure sample of each of these molecules. We've also given them the molar mass. And then you can ask them, you know, which compound has the lowest boiling point or the highest, doesn't matter, okay? And then you might ask them to explain their choice for part B. You might tell them you want them to use intermolecular forces that you identified in part A. So you're really specific about, hey, this is what I want you to write about. And you can also use the Lewis structures or any other relevant concepts. I would tell you that one of the things that we learned this spring that was very interesting on this, on the side of using the appropriate evidence, is that students tried to invoke the molar mass. and in this case, it's not all about the molar mass. And so that was one of the things to sort out with the students. What's the appropriate evidence and what's not? Okay, so let me morph over into laboratory. So I'm pretty sure I saw Joy's name here in the 141 people who were at this conference. And I think Joy might be a little bit disappointed because her advice would be go big or go home. And I didn't transform the whole laboratory curriculum. So I apologize, Joy. At the beginning of the semester, there were 3 laboratories that we transformed. And so what we did is, like many of the other speakers, I think Anna was talking about doing multi-week labs, and there was a comment in the chat about the importance of doing multi-week labs. I completely agree. It gives the students time for discussion and exploration and reflection about the data, their analysis and their interpretation. Relating it to claim evidence reasoning, it allows them to build it out. So let me just say a few things about that. So first of all, if you're going to do something like this, you got to figure out in your laboratory period, and we have 2-hour and 50-minute laboratory periods, what are you going to do? Because you need your demonstrators or your TAs to be able to manage this kind of laboratory. So yes, we have training for the TAs. We have weekly meetings, or for the demonstrators rather. But you also need to carefully think about, what's your roadmap look like? And this is actually the roadmap that we did for a titrations laboratory, where we wanted them to carefully think about, okay, what's the concentration of my monoprotic acid? Let me work on that. And I'm going to show you how we structured it real briefly, although it may kind of look like a mess to you. Our laboratories are set up in 6 rows and 24 students. So what you've got there at the top are students 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12. And then what you want to be able to do is to have those students work in pairs, like students 1 and 2 and 3 and 4 work together in a pair and talk about their laboratory data. But then you're going to send them away. You're going to break up those pairs, and it's close to what Joy talks about in ADI, where you have these big whiteboards and you start to talk about, okay, well, what's your claim? What's your data? What does your reasoning look like? And so in our case, we structured it more like a call and response. We had them look at some of their data in the, it's the second week of the lab. So they're looking at their data, they're comparing their analyses and trying to figure out, okay, what does this really say? And then if I go talk to people who are in different pairs, did you come up with the same kinds of reasoning and the same kinds of graphs and the same kinds of concentrations if you've got similar acids? So we've done that in 3 labs. Unfortunately, the 3rd lab was online. And let me tell you, the collaboration did not work very well at all. That collaboration was supposed to have happened in week 1 of online learning, and that really stunk. So the students really lost out there. But let me show you kind of a conclusion about this. We used it in lecture, we used it in lab, and we used it on exams. So we're really trying to drive the students towards being able to build an evidence-based argument. You can use tables, graphs, images, and video, and actually there is a CER task associated with the final. It has to do with experimentally looking at reducing strength. So, you're trying to reproduce part of the activity series. And what we've done is we've created videos, and they're linked on this sheet so students can go watch the videos. They have to fill out a data table and then draw some conclusions from that. And we've also, if people are also wondering, oh my gosh, if you're doing this on your final, and you must be doing this in some sort of untimed environment, you've set a task and the students have a deadline, that's correct. We use anti-plagiarism software to, help the students write in their own words and not use someone else's words. And the research results are coming. Actually, this is the first semester we've tried this. So what you're getting is sort of the top layer of, hey, this is what we're doing. We believe we're making some headway on improving students' abilities to craft an evidence-based argument, but the research results are coming. The last thing of the tasting menu, just rather quickly at this point. So we wanted to go to an online lab manual. So much like Magna and her poster about using OneNote and what Ian talked about with his materials, we've gone in that direction as well. So if you want to know the reasons, we have people here who are very concerned about the cost of a laboratory manual, people who are concerned about the use of paper, people who have gotten completely fed up with, well, if you're going to print a laboratory manual, then your laboratory curriculum has to be decided months in advance of the semester. And so going to an online laboratory manual, of course, lets you change the lab manual as you go. And when we had to rapidly go or pivot to an online mode, this just worked absolutely seamlessly. As you've seen in other presentations, and especially if you talk to Magna, you can add video, you can add color images, and you can auto grade some of the student report. And I'm not going to do a tour because I've only got 1 minute and 43 seconds left. But some of the management pieces are really important to us. So in the course I teach in the fall has 1,000 students. Here in the spring, it's got 747. So there's lots of demonstrators, lots of teaching assistants. So inside of an online manual like this, you can manage things at the section level and at the time of day. So all of our labs do not meet at once. They meet at 5 different times of the day, 3 on one day, 2 on another. So because you have an online manual, you can vary the pre-lab, you could vary the post-lab if you wanted to. You can also auto-grade some of the lab reports. So like Ian was talking about, marking time goes way down, and the teaching assistants really appreciate that. You submit your pre-lab and your lab report online. You just submit it and the TAs get it. It's in their section. They can grade it and work on it. You can upload pictures of student work, laboratory setups. You can do video. I do want to be really honest about what are the problems in this. And the biggest problem that we had is in this particular software, there's a save button at the bottom. So telling students to hit save turned out to be really, really, really important. And boy, did we get that figured out, because the students weren't happy when their data disappeared. Okay, last but not least, let me acknowledge a whole bunch of people that I've worked with. So the digital badging project, I have collaborated with Cindy Harwood every step of the way. She is a wonderful collaborator in everything that we do in Chemistry 111, 112. Sarah Heinsick, who's now Sarah Hewitt, and she's at MIT, was a graduate student who worked on that project and drove that forward. And then we had collaborators in teaching and learning technology at Purdue. The claim evidence reasoning project, again, Cindy's my big time collaborator. We think about all these things together. And Jessica Callis, that is her research in my group. Bluedoorlabs, really, that is Cindy's baby. She's the one who wanted to do it, and I worked with her long enough now that it's like, yeah, hey, sure, I'll do that. And then last but not least, thank you so much to Michael and Dino. This is just what our community needed in these times of COVID. I am more energized than I have been in weeks. To do more reading and more thinking. So thank you very much. And thanks to all our funders, the Purdue University College of Science Provost Office and the NSF. And that's it.
All right. Thank you very much, Marcy. Applause from around the world and through the chat room. Right, just let me gather my thoughts. Okay, so a couple of questions, if I can pass them on to you. The first one is, I think, are you okay there? Yep. The first one is about assessment time. This is something I'm asked as well, a lot about video assessment. How do you manage the assessment of all of these digital badge videos?
Gotcha. So a couple of true things. One is that by the time